For Unit 7, review number 1, I'm going to do some of the problems. They aren't going to be in any particular order. I just thought I'd start off with problem number 9. It's the problem that says we know what the focus is, -7, 2, so you can see I kind of already marked it. And we know the directrix is x equals 1, so again, I already marked that. Now, the reason you want to make a picture of this and start graphing it out is you already know some things about this parabola. The vertex is always halfway between the focus and the directrix, so I'm going to mark the vertex at about right there. And we also know the focus is always on the inside of the opening of the parabola, so I know this parabola must open to the left. So, this parabola does something like that. Now, the problem specifically tells us to use the distance formula. So, what that means is the definition of the parabola means every single point on this parabola is equally distant to the focus and the directrix. So, I'm just going to mark any given point, like right here. I have no idea what that point is. I'm just going to call it x, comma, y. And now I'm going to use the definition. The definition says the distance from the focus to that point is the same distance as the point to the directrix. Now I know I didn't draw it as if it looked like that, but let's just say those two things are equal, because that's what we're going to have to do to finish off the rest of the problem. Now, the distance formula, let's go from the point to the to the focus first. So it would be the square root of x minus 7, x minus -7, and square it. And then you would do the same thing with y minus 2. And square it. Now that distance equals this distance. That takes us to this other point, the point that lies on the directrix. We know one coordinate of that point. We know the x coordinate is 1, but we really have no idea what the y coordinate is, but we do know it's the same y coordinate as this point right here. So I'm going to put 1y. And now we're going to do the distance formula from this point on the parabola to that point right there. So it would be x minus 1 quantity squared plus, and in this case it would be y minus y quantity squared. So let's do a little simplification here. This is going to be x plus 7 quantity squared plus y minus 2 quantity squared equals x minus 1 under the square root x minus 1 quantity squared. But on this one, y minus y is 0, and 0 squared is still 0. So this part of the problem just kind of goes away. Now the next thing I'm going to do is I'm going to square both sides, which is simply going to get rid of the square roots. Okay, now at this point, I'm going to need to expand. I'm going to need to expand the x's because ultimately I have to combine like terms. I don't need to expand the y. So if I expand the x's, x plus 7 quantity squared is x squared plus 14x plus 49. Now I'm going to leave the y minus 2 as a squared term. But over here, I need to FOIL this out, and that would be x squared minus 2x plus 1. Now I'm going to do some simplifying. I've got an x squared over here and an x squared over there. So they're going to cancel each other out. I want to bring the x's over here. So I'm going to add 2x, and I'm going to add 2x. I'm going to bring the constant over here. So I'm going to subtract 1, and let's take a look at what we've got at this point. We've got 16x plus 48 plus y minus 2 squared equals 0. So I'm going to get that y minus 2 squared over there. So I've got 16x plus 48 equals negative, because when this goes over to that side, it becomes negative y minus 2 squared. Now we're seeing the equation develop to what we know it's supposed to do. We knew all along it was a left opening parabola. Well, this is going to be a left opening parabola. I'm going to factor out the 16, and I'm going to get x plus 3 equals negative y minus 2 squared. Now, as far as the problem is concerned, we're now done because the problem asked for focal width form. And that's exactly what this is. Now, we've studied another form of these too, the descriptive form. So I'm going to go ahead and take it even a step further. I'm going to multiply both sides by 1/16, and that would be x plus 3 equals negative 1/16 y minus 2 squared. And then I'm going to subtract the 3, and I'm going to be left with the equation as x equals negative 1/16 y minus 2 squared minus 3. Now that should look familiar too to you. That's just a different form of the equation. This is descriptive form. Okay, the next problem I'm going to do is problem number 6. This is the equation that was given to us, and it's asking for the vertex and the focal chord length. Well, we already know something about this parabola. Y is to the first power, and x is to the second power. So this is either going to be an up or a down parabola. And as always, if I look at the equation and I cannot tell what the vertex is simply from the equation, then that means I'm going to have to complete the square. So I'm going to keep the minus 5y and the minus 12 on one side. And I'm going to put the 2x squared minus 12x on the other side. Now, when the 2x squared moves over to the other side, it's a negative 2x squared. When the minus 12x moves over to the other side, it's plus 12x. And now I have to complete the square. Negative 5y minus 12 equals. I'm going to factor out the negative 2, and that leaves me with x squared But if I factor a negative 2 out of a positive 12, 12 divided by negative 2 is minus 6x, and then I need to complete the square. So half of negative 6 is negative 3. Negative 3 squared is positive 9. Now, because of that leading coefficient right there, I don't just add 9 to the other side. 9 times negative 2 is negative 18. So, that gives me negative 5y minus 30 equals negative 2 times the perfect square of x minus 3. Now the next thing I'm going to do is I'm going to move that negative 30 over to the other side. Negative 5y equals negative 2 times x minus 3 squared plus 30. And the last thing I'm going to do is divide both things by negative 5. So I'm going to divide this by negative 5, and it'll be y equals. Okay. Now, if I'm dividing this by negative 5, so negative 2 over negative 5 is 2/5 x minus 3 squared. And then if I divide this by negative 5 also, 30 divided by negative 5 is minus 6. So there's my equation in descriptive form. Now that tells me my vertex. Anytime I'm in descriptive form, I can simply look at the equation and I know what my vertex is. It's positive 3, negative 6. Now, focal chord length. My focal chord length is based on the C value. C equals 1 over 4 times the A value. C equals 1 over 4 times 2/5, which equals 1 over 8/5. And 1 over 8/5 is 5/8. But that's my C value. The focal chord length, the distance between the two focal chord endpoints, is actually 4C. So if C equals 5/8, then 4C would equal 28, which is also known as 2.5. After doing a couple of complicated examples, I thought I'd show you they're all not really hard. Problem number 7. Write the equation of a circle that has a center at 4, -1 and a radius of 8 square root 2. Well, for the x coordinate to be at 4, then that means the equation must have said x minus 4 squared. And for the center of the circle to have a y coordinate of -1, that means the equation must have said y plus 1 squared. Because remember, it's opposite. Now the last thing is, what would the number be in the equation if this is the radius? Well, this number always represents the radius squared, so all we've got to do is take 8 square root 2 and square it. Now that's just nothing more than 8 squared, which is 64, multiplied by 2. And 64 times 2 is 128. So 128 would go right there. And there's your equation. Okay, I'm going to do problem 13 now. In fact, I've added a couple of extra things to find about this parabola. Now, problem number 13, you can see the equation. The x is what's squared. The y is what is taken to the first power. So you know this is either going to be an up or a down parabola. Now, I happen to like descriptive form a whole lot more than focal width form. So when given the choice, I write the equation in descriptive form. So that's what I'm going to do. Now, the other rule stands that if you look at the equation and you can't figure out where the vertex is, then you're going to have to do some completing of the square. So I'm going to leave the y plus 15 on the left-hand side. And I'm going to take the x's over to the right-hand side. So that would be negative 1/4 x squared. And when the minus 4x goes over to the other side, it would become a plus 4x. Now I'm going to start the process of completing the square. Y plus 15 equals, I'm going to factor out the leading coefficient of the x squared, negative 1/4. There's my x squared now. Now, when I factor out a negative 1/4 from the number 4, it's like dividing. So 4 divided by negative 1/4 would be the same thing as 4 multiplied by negative 4. So that makes minus 16x. And then there's my third number that's going to complete the square, or at least there's the position for it. Now let's complete the square. Half of negative 16 is negative 8. Negative 8 squared is 64. But because of the leading coefficient, I don't add 64 over here. I add the product of 64 times negative 1/4, which is actually back to negative 16. So I'm now at this position. Y minus 1 equals negative 1/4. Now here's my perfect square that I just completed, x minus 8 quantity squared. And then the last thing I need to do is just put that 1 over on the other side. And now I'm in descriptive form. Y equals negative 1/4 x minus 8 quantity squared, and then plus 1. And the reason I like that form so much is because descriptive form tells you exactly where the vertex is. It's at positive 8, positive 1. So the first thing I know, the vertex is at positive 8, positive 1. Now I'm going to go ahead and mark that. Positive 8, positive 1. We're going to say it's somewhere about right there. Now notice the leading coefficient is negative 1/4. That tells us two things. It's down and it's rather wide. So I'm going to make a down wide parabola. Now, we also know there's a focus on the inside and the directrix is on the outside. Those two things can be found using the distance of C equals 1 over 4A. So C equals 1 over 4 times, the A value is negative 1/4. So that's 1 over 4 times negative 1 is negative 4 over 4. Because remember, the 4 gets multiplied by the 1. This is 4 over 1, not 4 over 4. So you don't multiply 4 times 4 down there. Now this is 1 over negative 1. which is -1. So C equals -1. Now the negative is simply an indication of the direction. I'm going to go down. So let's recap where this was in the first place. This was at 8, 1. The vertex was at 8, 1. So if I go down one step to find the focus, I'm at 8, 0. If I go one step the other way to find the directrix, I'm at 2. Now, the axis of symmetry, the line of symmetry runs right through the vertex. Half the parabola is on one side of it, and the other half is on the other. It's like a mirror, so it's x equals 8. Now, the number of x-intercepts. How many times does this parabola touch or cross the x-axis? Twice. How many times does it touch or cross the y-axis? Once. So there's problem 13.